Hi guys, welcome to class today. This is A Plus Academic Resource Center where we take online tutorials for undergraduates and senior secondary students. Thank you for liking, thank you for sharing our videos, thank you for subscribing. Alright, let's get down to business. Today we'll be looking at binomial distribution. In our introductory class on our TikTok page, which I'm going to post on the description section so that you follow us and see what we're doing there. Okay, we talked about various probability distribution we're going to be looking at. So today we're going to be looking at the binomial distribution, and we have given an introduction of what the binomial distribution is in our TikTok page, sorry. Okay, so now we're going to be looking at the properties of the binomial distribution. We're going to be looking at the formula, and we're going to be looking at other concepts that will help us to solve the binomial distribution and other discrete variables. Okay, so now there are four basic properties. I'm going to display them on the screen so that you can write or read, but in order to save time, I'm just going to give us a summary of them. Okay, now the first one is the first property is the number of trials is denoted by n. The number of trials is denoted by n, and they are fixed. Okay, n, and they are fixed. N, fixed number of trials, and is denoted by n. Okay, then number two, the outcome of our trial are either one or two possible outcomes. Okay, denoted by q, which is failure, and p, which is success. Okay, so your outcome can either be failure or success. That's what we're trying to say. Okay, now number three, the trials are independent. All trials are independent. They are mutually exclusive. They are independent. Okay, now the last one is the probability of success of every trial is constant. Okay, the probability of success on each trial, on every trial, is constant. That is to say, you must have successes in each trial. So there is constant probability of successes in each trial. Okay, these are the four properties of the binomial distribution. Okay, sorry, I'm a bit fast because we have questions to solve, and I don't want this class to be too long. Okay, so I'm going to paste the properties on the screen so that you see them. And also the question you're going to be solving, there are about two of them. I'm going to solve the first one, then the second one you're going to solve them yourself. You're going to try it out, okay? Then go to our Facebook page and take a screenshot of your solution and paste on the comment section on our Facebook page, okay? Now, the formula is given px is equal to nx pxq n minus x. Okay, n combination x, p raised to the power of s, q raised to the power of n minus x. Okay, so n is equal to number of trials, s is equal to number of successes, then p is equal to success, then q is equal to failure. Okay, so both success and failure must give you 1, is equal to 1. Okay, success and failure must give you 1. So if our success is 0.5, our failure is what? 0.5. So success and failure must be equal to 1. Then this is the formula for solving the binomial distribution. Now, for binomial distribution and other discrete variables, there are basic concepts that will help us understand how to solve them. Okay, now let's have p, open brackets, x greater than c is same thing as saying 1 minus p, open brackets, x less than or equal to c. Now, this one is the same thing as this. Okay, now if you solve any problem using this route or this route, you still arrive at the same answer. Now the question of which one to use, either this one or this one, depends on the volume of your computation, okay, which we are going to see when solving a problem. And I'm going to post, just like I told you, I'm going to display the question on the screen so that you can see it. Or you can go to our TikTok page or our Facebook page. On the comment section, you will see them. I will not be able to write them so that to save time and all that, okay? So now, this one is same thing as this. Now, again, when we have P, open brackets, X, C, is same as saying 1 minus P, open brackets, X, C. This is the same thing as this one. This one is the same as this. This one is the same as this. Okay, let's continue. So let's have another one. P, open brackets, X, greater than or equal to C is same thing as saying 1 minus P, open brackets, X, less than C. This is the same thing as this. Okay, let's have another one. P, open brackets, X, open bracket X less than or equal to C is same thing as saying 1 minus P, open bracket X greater than C. Hello, are we together? So this is the same thing as this. This is the same thing as this. So P, open bracket X greater than C is same thing as 1 minus P, open bracket X less than or equal to C. Then this one, P, S less than or equal to C equal to 1 minus P, S greater than C, okay? So P, open bracket X greater than or equal to C, okay, is equal to 1 minus P, open bracket X less than C, and all that. So this will help us in solving problems on binomial distribution, okay? So note this down. I'm going to wipe off now so that we can solve the questions, okay? Lest I forget, the binomial distribution has a mean and a standard deviation. The mean, okay, the mean is NP for a binomial distribution. When the standard deviation is equal to square root of NPQ, okay? This is the mean and this is the standard deviation for binomial what? Distribution, okay? All right. Now, the first question, the question here says, I'm going to display it on the screen, okay? 1/4 of all the accounts, 1/4 of all the accounts are found to contain errors in a batch of 5 accounts. Find the probability that the number of accounts containing error is 2 accounts, less than 2 accounts, more than 1 account. So we are solving 3 problems here. Number 1 is 2 accounts, less than 2 accounts, more than 1 account. Now let me explain this question. Now out of 5 accounts in a batch of 5 accounts, it was discovered that 1/4 of all the accounts are found to contain what? Errors. Now, the ones that are found to contain errors are our success. Remember I told you in one of the properties, success, the probability of success is constant in each trial, okay? So the error found there is our success, okay? So now, our N is equal to 5, our P is equal to 1/4 is 1/4. So our Q will be what? Okay, our Q will be what? Remember I told you probability of success and failure must give you 1. So if P is equal to 1/4, Q is equal to 3/4. Q is equal to 3/4. Okay? Then 1/4 account found to contain errors is a batch of 5. Okay, the probability of the number of accounts containing error is okay. So we have N is equal to 5, P is equal to 1/4, and Q is equal to 3/4. So let's solve. Okay, let me write this here. N equal to 5, P is equal to 1/4, Q is equal to 3/4. Now, solution. Sorry. Number 1. Number A. 2 accounts. So P is equal to 2. Will give us, remember our formula, okay? N, C, X, Q, Pn, Q, Q, N minus X, okay? n minus x. All right. So now, are we ready? Are we ready? Okay. So we are solving for two accounts, okay, equal to 2. So here we have our n is what? 5. Now this is our formula, don't forget. So 5c, our x is what? Our x is what? 2. Okay? P is what? 1 over 4. 1 over 4. X is what? 2. Okay? Q is what? 3 over 4. N is what? 5 minus x is what? 2. Okay? So 5 combination 2 is same thing as 5 factorial, 5 minus 2 factorial times 2 factorial. Okay? So 5 factorial will give us 5 times 4 times 3 times 2 times 1. Okay, don't worry about this. I'm going to do as we progress. Okay, just follow me, okay? As we progress, we're going to understand the concept of factorial, okay? When solving combination, okay? But just follow me, okay? Now, 5 minus 2 will give us 3. Okay, 3 factorial is 3 times 2 times 1. 2 factorial is 2 times 1. Okay? 5 combination 2 is 5 factorial, then 5 minus 2 factorial times 2 factorial. So 5 times 4 times 3 times 2 times 1. Then 5 minus 2 will give us 3. 3 factorial. So 3 times 2 times 1. Then times 2 factorial will give us 2 times 1. Okay? Then times 1 over 4 raised to the power 2 will give us 1 over 16. Okay? Times 3 over 4. 5 minus 2 is 3. Okay? So 5 times 4 times 3 times 2 times 1. 3 will cancel 3. 2 will cancel 2. 1 will cancel 1. So we are left with 20. 4 times 5, 20. All over 2 times 1, 2. Times 1 over 16. Okay? Times 3 raised to the power 3 will give us 27 all over 4 raised to the power of 3 will give us, don't forget this is in bracket. 4 raised to the power 3 will give us, this in brackets, don't forget, please. 4 raised to the power of 3 will give us 4 times 4, 16. 16 times 4. 4 times 6, 24. 2. 4 times 1, 4, 5, 6, 64. Okay? 64. All right, let's continue. So we're left with 20 over 2, which is give us 2 here 1, 2 here 10. So we're left with 10. 10 times 1 over 16 times 27 over 64. Okay? Okay, 2 here will give us 5. Okay? 2 here will give us 8. Okay? Okay, so we have 5 times 27 all over 64, which is equal to 5 times 7, 35, 3, 2 times 5, 10, plus 3, 13, all over 64, which will give us, sorry, let me use the calculator now. Okay, so 5 times 27 is 135. Okay, sorry, this is 8, this is 8 times 64, which will give us 8 times 64, let's see, 8 times 64, which will give us 512. Okay, so 135 divided by 512, 135 divided by 512, which is equal to 0.2637. Let's round off. 0.2637. So these are answer. Okay, these are answer. Now let's look at the second question. Less than 2 accounts. Okay, sorry, I need to wipe this off. I want to wipe this off. Okay, I can wipe this off. Okay, so less than 2 accounts. Less than 2 accounts. Simply x less than 2 accounts. Okay? Yeah, less than 2 accounts. Okay, now how do we solve this? Now, remember I told us from the concepts I gave us, where I say 1 minus p and all that, if you remember from the concept, it will help us solve this. Now, let me analyze in this manner. 1, 2, remember our n is 5. 3, 4, 5, okay? 1, 2, 3, 4, 5. Now, what we are solving for now is less than 2. Now, when we say less than 2, our focus is on 0 and 1. 2 is not included because it's not less than or equal to 2. It's just less than 2. So our focus is 0 and 1, okay? Now, when, like this now, between 0 and 1, then 3, 4, 5. Which of these have more computation? 0 and 1 is just 2. 3, 4, 5 is 3. So this one has less computation than this. So there will be no need converting. You know, when we have p bracket x less than 2, is same thing as 1 minus p bracket x greater than or equal to 2. This, which is this, is the same thing as this. But we cannot use this to solve because this one has more computation than this. Okay, look at it. Let me prove it to you. 1 minus p, open brackets, x greater than or equal to 2. Greater than or equal to 2 means that 2 is included. So we have 1, 2, 3, 4. So we have 4 computations to do, which is very big. Why not we stick to this one instead of this one? You see, I don't know if you understand it. That is how it's supposed to be. So whichever one that has fewer computation, that is the one you work with to save time. So s less than 2 is this. But if we want to work with the other concept, it will give us 1 minus p, open bracket, x greater than or equal to 2. So greater than or equal to 2 will be this one. And it has more computation than this. So we'll use this one, which is this. I don't know if you understand it. Okay, so let me wipe this off. So we are working with p brackets, a is 0. That's what we're working with first. Let's work with this one first. So our n is, remember we're working with 0 and 1. Since s is less than 2, 0 and 1 is less than 2. Okay, so n is 5, 0. P is 1 over 4, S is what? 0. Excuse me. Q is 3 over 4. N is 5 minus X is 0. Okay? So 5 combination 0 will give us 5 times 4 times 3 times 2 times 1. Then 5 minus 0 is 0. Okay? Is 0. Then 0. So basically we have 5 times 4 times 3 times 2 times 1 here, because the numerator is 0, because 5 minus 0, sorry, 5 minus 0 is 5, yeah. So we have 5 times 4 times 3 times 2 times 1. Then 0 here is 0. Okay? So this automatically will cancel this. So we have 1 over 4 raised to the power 0 is 1. Remember our law of indices. Okay, so 3 over 4 raised to the power 5 minus 0 is 5. Okay, so this will cancel this automatically. So we have 1 times 1 times 3 over 4 raised to the power 5. 3 over 4 raised to the power 5. 3 raised to the power 5. Will give us 243 all over. So 4 raised to the power 5 will give us 1024. Okay, 1024. So here we have 1 times 1 divided by 1 times 1 times 243 divided by 1124. So that will be 243 divided by 1024, which is equal to 0.2373. Okay? Okay, so that's that. So we have solved for 0 now. So let's solve for 1. Whatever result we get in 1, we'll now add it with this one to give us an answer. Okay? So for 1 now, it will be P is equal to 1. So we have 5, 1, then P, X is 1, okay, P is 1 over 4. 1 over 4 raised to the power of 1, then Q is 3 over 4 raised to the power of n minus x. N is what? 5 minus x, 1. So 5 combination 1 is 5 times 4 times 3 times 2 times 1 all over 5 minus 1 is 4. 4 times 3 times 2 times 1 times 1. Okay? Now times 1 over 4 raised to the power of 1, which is the same thing as 1 over 4, times 3 over 4, okay, raised to the power of 5 minus 1 is 4. Okay? So this will cancel this will cancel this, okay? So we're left with 5 times 1 over 4 times 3 raised to the power of 4, 3 raised to the power of 4, 3 raised to the power of 4 will give us 81 all over 4 raised to the power of 4, 4 raised to the power of 4 will give us 256, okay? So 5 times this divide. Let me just do the division. 5 times 1 times 81 divided by 4 times 3, 4 times 2, 5, 6, okay? So let's have 5 times 81, which will give us 405, okay? Excuse me, 4 times 256, which will give us 1024. So 405 divided by 1024. That's 0.3955. Now, to finish up our question, we'll now do this one here, this answer here, plus this one. Do you get it? This one plus this one. So we'll have 0.2373 plus 0.3955, which is equal to 0.6328. This is our answer. Okay, so the class is beginning to get long and I don't want that. So this third one, C, more than one account. You're going to try it by yourself. Then the question 2, try that also by yourself. You can screenshot your answers and send them in the comment section of our Facebook page or our TikTok page. Okay, send them there. I'll go through it and score you. Okay, so this is where we're going to stop. I don't want the class to be too long. If you have any question, go to the comment section and ask me anywhere you don't understand. I'll be more than glad to answer you. Okay, all right, thank you for sharing. Invite more people to be part of what we're doing here. After binomial distribution, we're going to look at Poisson distribution before the normal distribution. All right, thank you for your time. See you in the next class.